First question, prove 1 square plus 2 square plus 3 square plus n square is equal to 1 by 6 n plus 1, 2n plus 1. So first step is let s of n is equal to 1 square plus 2 square plus 3 square plus n square is equal to 1 by 6 n plus 1, 2n plus 1. Next is basic step. S of 1 is equal to 1 square is equal to 1 by 6 to 1 into 1 plus 1 into 2 into 1 plus 1, which is equal to 1, which is equal to 1 by 6 into 2 into 3. 1 is equal to 1. S of 1 is true. Next, induction step. Induction step is nothing but assume S of n is true for n is equal to k greater than or equal to 1. Next we will do S of k replacing all the n with s. So 1 square plus 2 square plus 3 square plus k square is equal to 1 by 6 k plus 1, 2k plus 1. Next, take this 2k plus 1 whole square now. So adding k plus 1 whole square on both sides. K plus 1 is equal to 1 square plus 2 square plus 3 square plus k square plus k plus 1 whole square is equal to 1 by 6 k plus 1, 2k plus 1, k plus 1 whole square. So now what you will do is, which is equal to 1 by 6 k plus 1 k plus 1 plus 1, 2 of k plus 1 plus 1. So basically first you will add everything, then you should ignore it and just you should see this formula. Wherever there is k you should add k plus 1. This you ignore, this side you focus. K plus 1, k plus 1 plus 1, 2k, 2 of k plus 1, 1 by 6 k plus 1, k plus 2, 2k plus 2, 2k plus 3. Okay, so once you get this answer, what you should do, to first s of k is there now, mark this as equation 1, then this equation you mark as 2. Right, comparing equation 1 and 2, s of k plus 1 is true. Then by principle of mathematical induction, s of n is true and n is greater than or equal to 1. Okay, next question you have is 1 square plus 3 square plus 5 square plus 2n minus 1 whole square, and by 3n 2n minus 1, 2n plus 1. Okay, so now what you will do again, s of n you will write is equal to not let. So first what you should do, first you should write let s of n is equal to this, then you should write basic step again. S of 1 is equal to 1 square, which is equal to by 3 into 1 2 into 1 minus 1, 2 into 1 plus 1. So 1 by 3 into 1 into 2 minus 1 is 1. 2 into 2, 1, 3. This will get cancelled. 1 is equal to 1. So S of 1 is true. Okay. Next we have induction step. Induction step again you will write. Assume S of n is true for n is equal to k greater than or equal to 1. Next again we will write S of k. Again here we have written now wherever n you have replaced that with k. Square plus 2k minus 1 whole square 1 by 3k 2k minus 1 2k plus 1. This is equation 1. Next we have 2k minus 1 whole square. So 2 into k plus 1. Replace k with k plus 1 minus 1 whole square. 2k plus 2 minus 1 whole square. 2k plus 1 whole square. So adding 2k plus 1 whole square on both sides. So S of k plus 1 is equal to 1 square plus 3 square plus 5 square plus 2k minus 1 plus 2k plus 1 whole square is equal to 1 by 3 k 2k minus 1 2k plus 1 plus 2k plus 1 whole square. Okay, after writing this what you will do is basically you will ignore this whatever you have written. You will write is equal to 1 by 3. Here you see k plus 1 2 of k plus 1 minus 1, then 2k plus 1 plus 1 1 by 3 k plus 1 2k plus 2 minus 1 2k plus 2 plus 1 1 by 3 k plus 1 2k plus 1 2k plus 3. So this is your equation number 2. So once you get this equation, what you will write again, you will write comparing equation 1 and 2. S of k plus 1 is true by principle of mathematical induction. S of n is true for S n is greater than or equal to 1. Okay, next we will move to third question. Third question again you have 1.2 plus 2.3 plus 3.4 plus n into n plus 1, then all square 1 by 3 n into n plus 1 n plus 2. So this is your question. So again we'll write let S of n is equal to like this. Again, then again basic step. S of 1 is equal to 1 into 2, which is equal to 1 by 3 into n into n. Sorry, 1 plus 1 1 plus 2. 2 is equal to 1 by 3. 2 1 into 2 into 3. 3 cancel. 2 is equal to 2. So you have 2 is equal to 2. So S of 1 is true. You will write true. Next induction step. Induction step again like this. Assuming S of n is true for n is equal to k greater than or equal to 1, then S of k is equal to 1.2 plus 2.3 plus 3.4 plus k into k plus 1, which is equal to 1 by 3 k into k plus 1 into k plus 2. Done. Equation 1. Now you have k into k plus 1 now. That is nothing but k square plus fine, wait. No, k plus 1 to k plus 1 plus 1, k plus 1 to k plus 2. So you should adding k plus 1, k plus 2 on both sides. So s of k plus 1, I'll write 1.2 plus 2.3 plus 3.4 plus k into k plus 1 plus k plus 1 k plus 2, which is equal to 1 by 3, k into k plus 1 into k plus 2 plus k plus 1 into k plus 2. So this you will write. For namesake, this is, I don't know how to solve, I'm teaching simple method. So you look again in this step only, s of k plus 1 you write. This again you should repeat here is equal to 1 by 3 k plus 1 k plus 1 plus 1 k plus 1 plus 2, which is equal to 1 by 3 k plus 1 k plus 2 k plus 3. So this is your equation 2. Once you get this equation, again you should write that. See, k plus 1 k plus 2 k plus 3. Wait, again comparing equation 1 and 2. This is equation 1, this is equation 2. S of k plus 1 is true by mathematical induction. S of n is true for n is greater than 1. Next question is a little bit different. So next question is 4 power n greater than n square minus 7, n is greater than or equal to 6. So this is the, okay, so you should write, since n is greater than or equal to 6, let n is equal to 6. Okay, next after this, s of 6 is equal to 4 power 6. I don't think it is 4 power 6. Wait, it is 4 into n, sorry. So it is 4 into 6 greater than n 6 square minus 7. So 4 6 is 24 greater than 29 it will come. This is 36 minus 7, 29. So this is true now, 29 is greater than. So s of 6 is true. Next we have induction step. I'll write here. Induction step is 4k. So s of k is equal to 4k k square minus 7. We have this, and k is greater than or equal to 6 we have. Next what we will do is 4k plus 1, 4k plus 4 will come, but 2k plus 1 is greater than 4k. So take this. So 2k plus 1 you should remember, this is y I will tell you. So 2k plus 1 you keep, okay. 4 into k plus 1. Wait, I don't know how to tell you, but let's see. So you wrote here now s of k. This one is equation 1. Okay, you can see. So this is equation 1. This I will tell 4k. So instead of k you are replacing with k plus 1. K plus 1 which is equal to 4k plus 1. Sorry, 4. Okay. So 2k plus 1 greater than 4. Okay. This you remember. Important this is. So s of k plus 1 is equal to 4 of k plus 1, which is less than k square minus 7, and here we will be adding that 2k plus 1. This you should remember this part. So 4k plus 4 greater than k square minus 7 plus 2k plus 1. So k square plus 2k plus 1 minus 7. This is in the form of a plus b whole square. K plus 1 whole square minus 7. That's 4 we have. Okay. This is your equation 2. So like to bring a plus b whole square, we will add 2k plus 1. Okay. That's all. This is equation 2. Write that again. You write comparing equation 1 and 2. This is correct. S of k plus 1. And principle of mathematical induction. S of n is true for n is greater than or equal to 1. Okay. So this is completed. Next we have one more question. It is fifth one. So n is greater than equal to 24 and they are given, then n can be written as sum of 5s and 7s for n is belongs to z plus. Okay, so basically n is greater than or equal to 25, sorry 24, so let n is equal to 24. So s of 24 is equal to 24, which is equal to 5 plus 5, sum they are given, 7 plus 7, 2, 5 plus 2 of 7, which is equal to 10 plus 14, 24 equal to 24. So s of 24 is true. Okay, next this is basic step, I forgot to write basic step. Next we have induction step. Induction step, what is there is n is equal to k, that we have to do. So s of k is equal to 24, which is equal to, we don't know how many, like we can do 5 plus 5 plus 5 also, 3 of 5 will happen. So this will write p of 5 plus q of 7, where n is, sorry, k is like this. Okay, now what we will do is we will do s of k plus 1 and one more we need to add q plus minus 2 plus 2 we should do. Keep this also in mind, I'll tell you why. Over s of k plus 1 is equal to p of 5 plus q minus 2 plus 2 into 7 plus 1 we need to do. This is k now, this is k, then q is equal to, like this we have done, and we will add k plus 1 now. This is k, this is plus 1, q 5 is plus q minus 2 plus 7, 7 2s is 14 plus 1, q of 5 plus, sorry, p, q minus 2 plus 15 we have now, p of 5 plus q minus 2, this we can write 3 into 5, so p of 5 plus 3 of 5 plus q minus 2, 5 common, we will write 5 into p plus 3 plus q minus 2. So wait, this into 7 is not happened here, I forgot to write that. 7 7 7 7 7. So this is equation 2, this is equation 1. I know I didn't understand we'll do again. It's okay, we'll just continue. Next is 11n plus 2 plus 12 2n plus 1 is divisible by 133. So now what we'll do is s of n, we'll write this, let s of n is equal to like this. So s of 1 is equal to 1 plus 2 plus 12, 2 into 1 plus 1, which is divisible by 133. So basically we'll get 1331 plus 1728, which is basically 3059, which is divisible by 133. We'll get a whole number. So s of 1 is true. S of n is base k. Again you'll write induction step. For n, s of n is true, n is equal to k, that you'll write. And here you'll replace nk plus 2 plus 12, 2k plus 1 you'll write, divisible by 133, and it is positive integer. So k belongs to z plus is what will happen. So sk plus 1 is equal to 11k plus 3 plus 12, 2k plus k plus 1, 3. Yeah. So now what happen is, you will separate 11 into 11k plus 2 plus 12 square into 12 2k plus 1. This you'll write 144 into 12 2k plus 1. Remaining you write like that only. So this we can write 11 plus 133. 11 plus 133 into 12 2k plus 1 k plus 2. Okay. Now what we'll do, 11 into 11k plus 2 plus 11 into 12 2k plus 1 plus 33, and also is equal to 13a will write. It means like it is divisible of some number. So this number, if you divide, you'll get like some number now. See, 3059 divided by 133, you'll get 23. So it is basically 133 into 23. Now you'll get the same number. So it is some multiple now. So we will do this with 133 into 12 2k plus 1. So here we have 11, here we have 11, we'll take 11 common, 11k plus 2 plus 12 2k plus 1 plus 133 into 1 12 2k plus 1. This is this, check, into 133a plus 13 into 12 2k plus 1. We have 13, so 13 to 11a plus 12 2k plus 1. Okay, 13b we can write like that. This is equation 2, this is equation 1. Done. Okay.